So, 25. What strategy you use to introduce the concepts of limits to senior high school students for the first time? So, if I'm going to introduce the concept of limits to senior high school students, I would start with a visual approach, but I will use graphs and numerical tables. For instance, or for example, I would present a simple function like f of x is equal to x squared minus 1 over x minus 1 and ask the students to investigate what happens to f of x as it approaches to one. By the using the graphing tool like Desmos, um, they or the students could zoom in and on the curve near x equals 1. And they can observe the values from both sides and use a table to estimate the function's behavior. This helps them grasp that the limit described as function's behavior near a point, even if it's undefined at that point. After the after building the conceptual understanding, I would introduce formal notations and eventually progress and to evaluate limits algebraically. Let's move on to number 26. How can you apply differentiated instruction in math class with mixed ability students solving word problems? Okay, so in a class solving world problems, I can apply differentiated instruction by offering tiered tasks that vary in complexity. This will allow my students to engage in an appropriate level, since we all know that our students are diverse learners. I might provide the same problem con- context, but adjust the numbers or required steps based on readiness. I can also offer scaffolds such as graphic organizers, highlighted keywords, and guided questions for students who need support. For advanced learners, I can include open ended um, extensions or multiple steps problems. And I can also use a flexible grouping so that my students can collaborate, peer teach, and model different approaches. This approach ensures that all students build problem solving skills at their own pace and in their while remaining challenged and supported. So let's move on to number 27. So, give an example. How would you implement inquiry based in a lesson on geometry? So, in an inquiry based geometry lesson on angles formed by parallel lines and a transversal line, I would begin by having students to use protractors or digital tools like GeoGebra to measure angles created when a transversal line intersects with two lines without initially naming the angle relationships. I would ask them to identify patterns and make conjectures such as when are the angles equal or what's the relationship between alternate interior angles. After collaborative discussion and reasoning, I'd introduce the formal vocabulary, such as corresponding angles and vertical angles and its properties. And this approach promotes active discovery, deeper conceptual understanding, and better retention for the geometric rules to my students. So let's proceed to number 28. If your objective for students is to solve real life problems involving linear equations, what activities and assessment tools would you include in your lesson plan? So, if I were to solve or if I were to make an objective that would solve real life problems involving linear equation, I would include activities such as budget planning, calculating speed and distance, and analyzing phone data plan cost using, of course, the equations, linear equations. My students could work on tasks like comparing two job offers with different hourly wages and bonuses, forming equations to represent each, and finding break even points. As assessment tools, I'd use performance tasks, exit tickets, and rubrics that evaluate not only one or the solution, but the reasoning and application of the equation. Um, a self reflection component could also be included by asking the students or asking my students to explain how they modeled the problem mathematically or algebraically. So let's proceed to number 28. How do you incorporate multiple representations like verbal, graphical, symbolic, numerical in your math lesson? So I incorporate multiple representations by, for example, when me, when I'm teaching linear function, I'll start with a real life scenario. So this can be considered as verbal. Then translate it into a table of values so that it can be easily understood by my students, which we can know as a numerical value. Then graph those values in order for them to see the flow of the values given. And of course, derive the corresponding equation, which we can know is symbolic. So then I asked my students to explain the connections among the forms. Um, what does the slope mean in the context? Or how does the y-intercept appear in the table and graph? This approach will deepen the understanding and support my diverse learners, as students can approach the content in ways that make sense to them and develop fluency across different formats. So we can move on to question number 30. What common misconception do students have about dividing fractions, and how would you address it? So, as we all know, that fraction is one of the hardest and commonly or misunderstood by our students. So, one common misconception that I think that I have encountered was some students divide the numerators and denominators directly. Just like, for example, 3/4 divided by 1/2. They tend to divide 3 divided by 1 equals 3. 4 divided by 2 is equal to um, 2. So they'll arrive with 3/2 or um, 1.5. So, which we all know that is incorrect. To address this misconception, I can use visual models or visual representations such as fraction bars or diagrams to show what division actually looks like or what division actually means. It's like, and how many times a specific thing is divided, right? And fix, and if it fits to one another. I can also emphasize the multiply by the reciprocal rule after the students conceptually understand the division of fraction represented before. I can also use real world examples, just like how many half cups fit 3/4 of a cup, that would help them to grasp the concept in concrete and, of course, before introducing the algorithm. But yes, of course, after giving the visual representation, I would really give them the way on how to divide fractions accordingly so that they will know how to do it. So let's proceed to 31. How would you help a student who consistently gets confused between mean and median? So I will help the students or the specific student that is confused with mean and median. I can use visual and hands-on activities or methods. Like, for example, I'd let the students arrange physical objects like number cards or scores in order to identify the middle value, or as we all know, the median, and let them add it all or combine it all and divide it so that they will know the average or the mean. I can also relate them to real world contexts, such as like comparing average scores, which I've mentioned earlier, and the middle score in a competition. And I can also use graphic organizers, anchor charts, and mnemonics like median, middle, so that um, they can remember it easily. And also that for mean, it can be average so that they will know the difference of each. So I'd also create practice sets where students compute both and explain the difference in their own words. So I'll go with number 32. I'm sorry. How would you use error analysis in students' work to guide your next math lesson? After collecting students' work on solving equations or graphing functions, I analyze common errors, for example, forgetting to apply the distributive property or plotting points incorrectly. I then create mini lessons or targeted practice activities that address these specific misconceptions. And sometimes I can present anonymous students' error and to the class and ask them to identify and correct, promoting the discussion and metacognition. Error analysis is not only in forms of instruction, but it also helps students to develop a growth mindset and understand that mistakes are a part of learning. And it also ensures that my next lesson is responsive and focused on what the students actually need. So let's move on to number 33. Which digital tool or app would you use to teach graphing functions? And how would it help the students to understand the topic better? So if I'm going to use a graphic tools or an app, I would use Desmos to teach graphing functions because it allows the students to explore how changes in equations affects graphs in real time. For instance, when teaching y equals mx plus b, students can manipulate the values of m and b using sliders and immediately see how the slope and the y-intercepts change the line. This visual feedbacks also supports conceptual understanding, especially for students who struggle with static graphing. Desmos also allows for layering multiple graphs, making it easier to compare different functions or visualize transformations. So, as we all know, that some students, of course, are really having a difficulty in graphing. So, Desmos can be a very great tool to let our students check if their graphing is correct or not. And it gives instant feedback for them that they can realize that they did the wrong graph. So let's move on to number 34. How do you ensure that calculators enhance learning rather than hinder number sense in math classes? So, to ensure that calculators enhance rather than hinder learning. I can set clear expectations for their use. I can allow calculators primarily for complex computations after students have demonstrated the understanding of the underlying concepts manually. For example, students might solve the first few problems by hand and then let them use calculators to check or extend their work. I can also incorporate estimation activities so students develop a sense of reasonable answers looks like what reasonable answers looks like before using a calculator. I by this I can emphasize mental math and number talks alongside calculator use. And my students can strengthen number sense while benefiting from technological efficiency when appropriate. Such just like Mom Normina told us last week that why does teacher don't allow their students to use calculator when we all know that that is a technology that would help our students to make their work efficiently. So that's what I've mentioned. Of course, first I will let them do it manually because um, we all know that some students tend to be not um, uh, in order for this so that I can know if my students does know basic arithmetic. Then after that, I can let them use their calculator so that their answer will be their process of answering the questions given will be efficient since they have the aid of technology. So let's move on to number 35. How do you manage group dynamics when using collaborative problem solving in a math class? So, managing group dynamics in a collaborative math problem solving involves clear structures, assigned roles, and ongoing monitoring. Since we all know that students may be sometimes just laying around and not doing their tasks. So we really need to have clear structures, we need to assign roles and keep on monitoring them. So I can establish roles like facilitators, recorder, presenter, and checker to promote accountability and balance participation. I'll use the norms and expectations for respectful listening, taking turns and staying on task. Groups are formed intentionally, of course, considering students' strength, communication styles, and learning needs. I can walk around, observe interactions, and provide prompts or supports as needed. After the group task, I I'll conduct self and peer evaluations to reflect on the group's dynamics and make improvements. This structure ensures that collaboration is productive and focused on math learning rather than mere grouping. That when roles are given to all the members, they will need to do something rather than the leader will do it all by themselves. 36. What strategies can you use to keep students engaged during drill and practice activity? So, in order for me to keep my students engaged during drill and practice activities, of course, I will incorporate like gamification, time challenge, and peer collaboration. For example, I might turn solving linear equations into a math relay where teams solve and pass the next problem along. I also I can also use digital tools like Kahoot and quizzes, which can turn drills into interactive quizzes with instant feedbacks, and also Canva. I can use that. Another strategy is to use differentiated question sets where students choose difficulty level, such as easy, medium, and hard, which can build their ownership and motivation towards the activity. And finally, I can frame drills as opportunities to improve speed and accuracy, and also emphasizing personal growth over competition to maintain a positive and focused environment. So let us proceed to question number 37. Describe a math lesson you taught or observed that didn't go as planned. What would you change and why? I once observed a lessons on solving quadratic equation by factoring, where the teacher assumes students already understood factoring well. But however, many students struggled to identify correct factor pairs and became frustrated or unmotivated. As a result, most couldn't proceed to solve the quadratic equations. If I were to reteach the lesson, I would first review factorial of binomials and trinomials using visual aids like um, models or area models or algebra tiles, the little plastic tiles. And I would also use scaffolding. I will scaffold the lesson by grouping problems or by um, depends on the difficulty, and I will be providing guided practice before um, moving to independent work and checking for prior knowledge. And to start, I would check for prior knowledge before I start so that I will know if the students really did understand the lesson or if they have difficulty in the past lesson or the prerequisites of the lesson. So the next one is number 38. How do you know if your students truly understand a mathematical concepts beyond just getting the correct answer? So, true understanding in mathematics goes beyond correct answers. It demonstrates through a student's ability to explain their reasoning, connect concepts into other topics, and apply it to new situations. I ask students to justify their answers verbally or in writing, and also use multiple representations like drawing, diagrams, or graphs, um, and also solve non routine and real world problems that require transferring the concepts into real life situation. I can also conduct error analysis in discussions and ask probing questions like, I'm sorry, why did you choose that strategy? Or what would happen if you're not going to use this strategy? So these methods reveal whether the students really grasp the underlying principles or just mimicking procedures. So number 39. What professional development activity has influenced your teaching philosophy the most? So it was a symposium. It was named Special Education Trends and Practices Across Cultures. So it emphasized that students should be encouraged to value mistakes, embrace challenges, and develop conceptual understanding over rote memorization. This changed my approach to instruction because I became more focused on fostering a safe learning environment where students aren't afraid to um, fail and are encouraged to explain their thinking. Um, it also shifted how I assess learning, focusing more on progress and process rather than just correct or wrong answers. This philosophy now guides me in how I do my lesson plans, give feedbacks, and support students' growth. So, last question is 40. Can you design a short formative assessment to check the understanding of after teaching the Pythagorean theorem? So, sorry, a short formative assessment to students understanding after teaching the Pythagorean theorem can include mixed conceptual, computational, and reasoning tasks. So, for example, I might start in a multiple choice question, and I'll ask students to identify which set of sides length could form a right triangle, um, such as recognizing 3, 4, and 5 can satisfy the theorem. Then I would include a real life application problem like calculating how high a 10-foot ladder reaches or a wall and on a wall when its base is 6 feet away. To assess the conceptual understanding, I would ask the students to explain how they determine whether a triangle is a right triangle using the theorem. Lastly, I would include an error analysis task such as evaluating whether the student is correct in claiming that a triangle with side lengths 6 cm, 8 cm, and 10 cm is not a right triangle, and to justify their answers. Um, these varied tasks help ensure that students not only know how to apply the formula a square plus b square equals c square or the Pythagorean theorem, but also understand when and why it is used, and making their learning visible and actionable for further instruction. So that would be all, and thank you. Goodbye.